Hey, good morning, ladies and gentlemen. Today we're going to be starting lesson 11, or excuse me, 12.1, adding and subtracting rational functions. This is typically a unit many students struggle with because it's dealing with fractions, and these fractions now have a lot of variables in them. All right, so we took our test yesterday. Today we're going to hammer through adding and subtracting rational functions here when we're done. Complete 12.1 Toyo. Tomorrow we're going to do multiplying and dividing fractions. And Thursday we're going to be doing 12.3 for everybody there. And we have a Toyo to complete every day. This week we're going to ask a little bit more of you guys on Friday. We've given you that off almost all year long. We're going to ask you to complete a formative assessment, most likely in its learning. And it needs to be turned in then. So let's get a roll on here. And why don't you just hit pause here and without a calculator, add and subtract the following fractions, all right? For instance, number one, I'll do the hard one for you. Number one, because my denominators are already common, all I need to do is I need to add 2 plus 4 to get 6, and then I must reduce 6 over 9, there's a common factor of 3, gives me 2/3 is what that is. So why don't you hit pause, add these last fractions, and we'll be back. Get common denominators first, though. Okay, so we're back, and we don't just want to multiply everything together for common denominators. We want to make sure we are finding the least common denominator, not the old fail-safe, let's just multiply all the denominators together. Well, the least common denominator between 5 and 60 is the least common multiple, which would be 30, and that's going to give you 12 over 30 plus 25 over 30. Denominators are the same. Add the numerators, 37 over 30. As long as that's reduced, you can leave it that way. Or if you want to be a mixed number freak, you can call it 1 and 7 over 30. And then when we move to number 3, well, the least common denominator of 8 and 3 is going to be 24. So I multiply the first one times 3 over 3, second one times 8 over 8. That gives me 21 over 24, minus 8 over 24. Once my denominators are common, okay, once they're the same, I can subtract the numerators. I get 13 over 24. 13 over 24 does not reduce. 13 is prime, so I circle my answer. The last one, the least common denominator between 7, 3, and 6 is 42. How did you know that so fast? Well, I know if I prime factorize that, that's 1 times 7. If I prime factorize that, it's 1 times 3. If I prime factorize that, it's 2 times 3. My least common denominator is going to consist of all these numbers. 7 times 3 times 2. Everybody needs a 7, a 3, and a 2 in the denominator. You multiply them all together, we get 42. So that's why I knew the first one needed to be 6 over 6. The next one, my 3, it needed the 7 and the 2, so that's why I multiplied it times 14 over 14. The last one's 7 over 7. Well, get your denominators all the same. Right here, I get a 42, a 42, a 42. Once they're the same, what I do is I like to put together my positive numbers first, so I put those two together, get 52 over 42 minus 35 over 42. Subtract those, I get 17 over 42. Remember, the denominator always stays the same for adding and subtracting fractions. And 17 over 42, 17 is prime, therefore I am done-zo with that. Well, what are we going to do here? Well, we're going to go on to not really group exploration, but what we do here is I have a couple examples going through. Well, an example of rational numbers, let's just get a common denominator between 5, 3, and 15. That would be a common denominator of 15. So we had to make sure every denominator had 15. Well, we multiply it by 3 over 3 or 5 over 5. Well, what happens if there's variables in the numerator? Absolutely nothing changes, okay? So now what we're doing here is we are changing. Here is my denominators, okay? The least common denominator between 3, 5, and 15 is still 15, so the first fraction gets multiplied by 3 over 3. The second one needs a 5 over 5. The third fraction already has the common denominator of 15, and the last one needs 3 over 3. And now remember, that's a quantity of 2x plus 3y. times 3. So as I do this, I'm going to get my common denominators, and I get 9x over 15 because I multiply this and I multiply that. I distribute here. And then what I do, once all my denominators are the same here, all I got to do is add and subtract the top. Well, it's 9x plus 10y minus 2 minus this whole quantity. And that's really important to see the minus the quantity because that little bugger is going to get distributed, and both of those are negative in top. Then, once I get all my signs straight, I'm just going to collect my x's. Well, I got 9x minus 6x, that gives me 3x. Then I get 10y minus 9y gives me 1y, and I got a minus 2. And nothing here reduces because I can't factor anything on the top, okay? So we're going to calculate each sum or difference. Make sure to use the least common denominator, okay? You want the least common denominator. So once you hit pause, go find these least common denominators, and we'll be back. Okay, I don't think it takes a whole lot of thought process here to find the least common denominator between 6, 4, and 8 to be 24. But if you're struggling with it, prime factorize the number 6, that's 2 times 3. Prime factorize the number 4, that's 2 times 2. Prime factorize the number 8, that's 2 times 2 times 2. That means every denominator needs 3 2's and a 3, which 2 times 2 times 2 times 3 is 24. So that's how I know this first one, okay, this first one's a 6. I need to multiply this one times 4 over 4 because 6 has 1, 2, and 1, 3, so that gets rid of those, so I need 4 left. The next one times 4, it's got the 4, so this needs times a 6 and a 6. So this is kind of an important process in how you're finding the least common denominator because you don't want to do what many of you have done your whole life, just multiply them all together. We want the least one, or we are going to run into troubles trying to simplify our fractions today, all right? So, as I cruise and bruise along here, well, then I just go through and I multiply them through. I get my common denominators. I multiply the numerator. 4 times 3 is 12. 6 times 5x is 30x. 3 times y is 3y. Well, now that all my denominators are the same, I'm just going to add and subtract all the numerators. So that's 12 plus 30x minus 3y. And all I did is I rearranged them. Okay, I really kind of looked at this as 24. I said 12 plus 30x minus 3y. And I like to write my fractions in appropriate mathematical order, which is usually descending order according to the powers and alphabetical x's, y's, z's, and so forth. So then I noticed here, does anything reduce? Well, I saw I had a greatest common factor of 3 that I could factor off the numerator so that I could reduce the 3 with the 24 to end up with 10x minus y plus 4 over 8, okay? And my common denominator on the next one here is 12. So I multiply the top. Notice that's there's 2 things up here that are getting multiplied by 4, so I have to remember to distribute that 4 to both of them. Then after I get my common denominator, I'm just going to add all the numerators. I'm just kind of looking at it like this, like so, and I'm just adding them all across the top. And then I'm going to put together all my like terms. I got 4x and x, that gives me 5x, negative 8y minus 8y minus 3z. There is no common factor between 5x, 8y, and 3z to factor out. Therefore, I know this does not reduce, and I circle my final answer there. You only reduce by common factors. You may not reduce the 8 and the 12 or the 3 and the 12 because the 5 does not reduce with the 12. All of them have to reduce, all right? So, well, what happens when there's variables in the denominator? Everything changes, all right? Everything changes. I'm going to picture this as an x. I'm going to picture this as an x times an x because it's x squared, so there's actually 2 factors of x down there. And this is just a factor of x plus 4. So I can see my least common denominator is going to be an x squared and an x plus 4. This 1x here is already there. So each denominator needs at least 2 x's and that x plus 4. So there's my least common denominator. So what did I do? Well, what I did was I came to the first one and I said, hey, that needs an x and it needs the x plus 4. So that's why I multiplied top and bottom by that. The second one had the x squared. It needed the x plus 4. And the last one had the x plus 4, but it needed the x squared here. So that's why I multiplied that by x squared over x squared. Well, then I'm going to distribute here the top. So that's where the x squared plus 4x comes from. And 1 times that, that's just x plus 4. And 1 times x squared is x squared. So now I can see my denominators here. They're all the same. So all I'm going to do is I'm going to add my numerators. X squared plus 4x plus x plus 4 plus x squared. Then I'm going to combine my like terms. That's going to be a 2x squared. This gives me a 4x and an x gives me a 5x plus 4 gives me 4. And that does not factor in any way, shape, or form, so I can't reduce it. But it says this is my answer, but for x that is unequal to 0 and negative 4. So the question is, why are there restrictions of x cannot be 0 or negative 4 for this original equation? Why can't it be there? Well, that is because you can never divide by 0. Okay, because when you divide by 0, it's undefined. Therefore, if it's undefined, we exclude those values of x from our domain. So these are my restrictions. X can never equal that here or here. And you might be saying, well, I can see that here. Well, a lot of times our fraction will reduce, and you won't see that restriction. But if it needs to be restricted in the beginning, it needs to be restricted in the end, all right? And that's what restrictions are. They make us divide by 0. So calculate the least common denominator for each sum or difference. Well, bottom line, I got to look and I got to try to factor everything, and each factor needs to be represented. So my least common denominator is going to be an x plus 4 times an x minus 4. That's my least common denominator. What are my restrictions? X cannot equal negative 4 or 4 because that's what makes my original function equal to 0 in the denominator. How about number 2? Well, nothing factors. That's linear there. Well, how about on the second one? Well, I need to try to factor that. That's going to be a 3x times an x. My signs are opposite, and I'm thinking, plus 3, excuse me, plus 3 to give me 9, excuse me, minus 2, because 9 minus 2 gives me my 7. So my least common denominator is everybody has to have a 3x minus 2 and an x plus 3 in the denominator. That's how I'm going to find my least common denominator. I'm just going to come back and say, I do not want to take this times this to get a cubic denominator because you're going to run into problems. What are my restrictions? X cannot equal 2/3 or negative 3. Those are my restrictions that I can't use there. Which means my answer key is kind of jacked up. I have negative 1, but that actually needs to be 3. I got something on it. Fix that. Oh well. What are my common denominators on number 3? Well, I need to go through. That's factored, that's factored. This is x plus 4 times x minus 4. So what's my least common denominator? Well, everybody needs an x, everybody needs an x minus 4, and an x plus 4. See, that last fraction already has the x minus 4, so I don't need to list that again. So my least common denominator is here and here. I will list my restrictions off my denominator. X cannot equal 0, 4, negative 4, or 4. And those are my restrictions. Do I have to list these in any particular order? No, I personally don't care. So when I look at number 4, well, number 4, notice I don't want to just multiply these together. I need to factor these little dogs. And this is going to factor to what? X, my signs are the same, 2 and a 3. And as I'm coming down here, this one's going to factor to what? An X and an X, and a -3 and a -3. So when I'm checking out my least common denominator, notice this one has 2x minus 3's. This one has 1, and everybody needs. So everybody needs 2x minus 3's and 1x minus 2. So my least common denominator, I could say, is x minus 2 times x minus 3 quantity squared. So my restrictions are x can never equal 2 or 3. Those are my restrictions. Okay? So what are we going to do here? Well, now we are going to do it all. Okay? Calculate the sum or difference. Make sure to list restrictions for the variable and simplify the answers when possible. Well, what do we need to do first? We need to figure out what is our least common denominator. That's what we want to figure out first. How do we find that out? We factor all of our denominators. All right? That's how we do that. And that one's already factored. So then we go back and we look. Everybody needs an x plus 3 and an x minus 3. That one already has the x minus 3. So my least common denominator is going to be x plus 3 times x minus 3. So what I'm going to do here is I'm going to say 5x minus 6 over x plus 3 times x minus 3. I'm going to leave it factored, minus 4 over, this has the x minus 3 already, but it doesn't have the x plus 3, so I got to give it the x plus 3. Well, as I continue along, well, now my denominators are really the same. I got 5x minus 6 over x plus 3 times x minus 3. I never multiply my denominators, minus 4x plus 12, x minus 3, x plus 3. The next spot here is where a lot of people make mistakes, okay? So when I put these together, I have a denominator of x plus 3 times x minus 3. Well, that gives me a 5x minus 6 minus, that's the whole top of 4x plus 12 up there, because I'm subtracting this whole top piece, which means I need to distribute that little bugger. Okay, that's a very common mistake. So I'm going to say 5x minus 6 minus 4x minus 12 over x plus 3 times x minus 3. Then I'm just going to combine my like terms on that. My denominator, again, it stays the same. Didn't do anything to it. And on the top, I'm going to have x minus 18. Well, the numerator's factored already, right? And because the numerator's factored and nothing reduces, here is my answer to the problem, but my restrictions are x can never equal. I got to come all the way back up here and say they can never be -3 or 3 or 3. So my restrictions are x cannot equal -3 or 3. And that is how we add and subtract rational functions. Okay, your calculators aren't going to do them. So why don't you hit pause and give number 2 a run here, and I will be back. Okay, so in number 2, what I'm going to do first is I'm going to factor my denominators. And when I factored my denominator, then I go through and I compare what do we all need to have the same amount of every factor. Well, the first one's got an x minus 2 and an x minus 1. The second one's got an x minus 5 and an x minus 2. The first one is missing an x minus 5. The second one's missing an x minus 1. So there's my least common denominator. And I will add the functions that I need. Now, I have more work than I really have to show here. To be honest, typically, up here, I would say this is, I'd multiply these right above here, and I'd say it's x squared, and I'd say minus 5 minus 7 gives me what? Minus 12x plus 35. And then I would call this a 4x minus 4 up here. And because now I know I'm just adding the tops of all of these right here, I typically would expand on the top, and then I would juke and jive myself right down here, and I'd skip these middle steps because it saves me time and anguish, all right? So I would put these together. Here's my common denominator, and I would combine like terms. I'd say I got an x squared, so I write my x squared. And then I got minus 12x plus 4 gives me minus 8x. and I'd say 35 plus negative 4 gives me 31. Then I would try to simplify this, but 31 is prime, so the only factors of 31 are 1 and 31, which means it's not going to factor. And I need to list my restrictions, meaning if I can never plug in 1, 2, or 5 in the original function, I can never plug 1, 2, or 5 into my new function that I just added together, all right? So why don't you hit pause, try these last two, and I will be back with the answers on both of them so we can be done. So as you're looking at number 3 here, your least common denominator is going to be a 5 times an x. So obviously you can see is what I'm going through here is I'm adding in red which factors are needed in the denominator. Then I distribute that 5 to the top. See, I got 10x minus 25, and minus 4 minus, I get 20x. Now the other thing I can do for you guys, just to show you, is another thing I like to do here to get to my end to save this middle step that I got right here, is I like to try to say, this is minus, so I know I'm adding a negative, I'm adding a negative. And then I'm just going to go to bypass this middle step, I'm going to take 10x minus 20x gives me negative 10x, and I got 25 minus 4 to give me negative 29 over 5x, and I can't factor that, and then I will list my restrictions of x cannot be 0, okay? So give the last one there, the last one's a beast. If you can handle number 4, you can handle them all. Be back. Okay, so I come through and I factor the denominator. Notice this one has 2x plus 3s. The second fraction has 2x plus 3. The last fraction has a 3. So everybody needs 2 of these and 1 of these. There's my least common denominator. So then I'm coming through and I'm adding the 3 to the first one. The second fraction needs a 3 and a 2x plus 3. The last fraction has a 3 and it needs 2x plus 3s. So then what I do is I come here and I'll distribute and I get 9x minus 15. And I look at this, I'm like, hey, you're 12. And I'll distribute 12 in here to get 24x plus 36. And then up here, I'm thinking of this times, that's my 4x squared. And then that gives me, what, minus or plus 12x plus 9. And I picture my 2x distributing here to get down here on the top, which is 8x cubed plus 24x squared plus 18x. Now, that's just how I kind of shorthand my work a little bit. Now to get to the next section, I'm going to write everything over 3 times 2x plus 3 quantity squared. That just, by putting the quantity squared, just shorthands what I'm going to do. Now, here is the kicker that people forget. They forget to distribute that negative to every term on the top. Whenever I'm subtracting a fraction, I need to distribute that negative to every term on the top. So that actually gives me 9x minus 15 plus 24x plus 36 minus 6x cubed minus 24x squared minus 18. Then I go through and I write everything in descending order. There's my biggest kahuna. There's my negative 8x, and I take my squares, and I write my squares. And then I'm going to say negative 18 plus 9 is negative 9 plus 24 gives me, what, 15. Negative 9 plus 24 should give me 15. And then I got negative 5 plus 36 gives me 21. Now, I can look to see if I'm going to factor this thing, but there's no greatest common factor that's going to factor out of all 4 of these terms. Okay, I'd have to factor by grouping. And then don't forget to list your restrictions. Please remember, when you list restrictions, you come all the way back to the top. What is restricted in the beginning? The only thing restricted in the beginning is that negative 3 over 2 is what x can't be. That constant of 3 doesn't have a restriction because it doesn't have an x with it, and that is how we add and subtract fractions. So what you can do is you can do your 12.1 try on your own. I think there's like 5 problems, and please work hard on them because this next test is not going to be a picnic for a lot of people. Have a great day.